0G is where everything begins. Before mobile networks even existed, communication over distance without wires was already happening. This period, roughly from the 1940s to the 1970s, is what we call 0G. It wasn't cellular, it wasn't digital, and it definitely wasn't smart. It was basic radio communication. If you wanted to make a call, especially from a car, your signal would go to a human operator. That operator would manually connect your call to another line. There were no cells, no towers handing off signals, and no automation. Because of this, only a very small number of people could use this system at the same time. It was expensive, limited, and not accessible to the public in the way we think of mobile networks today. Then came 1G, the first true generation of mobile networks. 1G introduced the concept of cellular networks. Instead of one large coverage area, the region was divided into smaller sections called cells. Each cell had its own tower, allowing more users to connect at the same time. This was a huge step forward. However, 1G was still analog. That means your voice was transmitted as continuous radio signals. Because of this, calls were not secure. Anyone with the right equipment could listen in. The quality wasn't great either, with a lot of noise and interference. Still, it allowed people to make real mobile phone calls without operators, which was revolutionary. Next came 2G, and this is where things started to feel more modern. 2G switched from analog to digital communication. Your voice was converted into digital data, which made calls clearer and much more secure. But the biggest change with 2G wasn't just calling, it was messaging. SMS or text messaging was introduced with 2G. For the first time, people could send short written messages instantly. This changed how people communicated globally. Networks also became more efficient, allowing more users to connect at once. Technologies like GSM and CDMA powered 2G networks, and phones became smaller, more portable, and more widely available. Then came 3G, which brought the internet to mobile devices. With 3G, mobile networks were no longer just about calls and texts, they were about data. You could browse websites, send emails, and even make video calls. Speeds were much faster compared to 2G, making mobile internet actually usable. This is when smartphones started becoming popular. Apps, social media, and online services began to grow because people could now stay connected on the go. 3G made mobile devices more than just phones, it turned them into portable computers. After that came 4G, which focused on speed and performance. 4G made mobile internet fast enough to handle high-quality video streaming, online gaming, and large downloads. It introduced technologies like LTE, which significantly increased data speeds and reduced latency. With 4G, everything became smoother. Watching videos in HD, using apps in real time, and browsing without delays became normal. This is also when services like ride-sharing, video streaming platforms, and cloud-based apps really took off. 4G networks are fully digital and optimized for data, not just voice. In fact, even voice calls are often transmitted as data using technologies like VoLTE. Then we move to 5G, the current generation that's still expanding. 5G isn't just about faster speeds, although it is much faster than 4G. It's about extremely low latency and the ability to connect a massive number of devices at once. This means near-instant communication between devices. Things like self-driving cars, smart cities, and advanced IoT systems rely on this kind of network performance. 5G uses higher frequency bands, including millimeter waves, which can carry more data but have shorter range. That's why 5G requires more towers placed closer together. It also uses advanced technologies like beamforming and network slicing to improve efficiency and customize network performance for different uses. And finally, 6G, which is still in development. 6G is expected to take everything even further. Speeds could be up to 100 times faster than 5G, with almost zero latency. It may use extremely high-frequency signals like terahertz waves and integrate artificial intelligence directly into the network. The goal of 6G is not just communication, but intelligent communication, networks that can think, adapt, and optimize themselves in real time. It could enable technologies like holographic communication, fully immersive virtual environments, and seamless interaction between the physical and digital worlds.